so I won't have to talk too much about me. I'm just gonna say that in the past years, I've been trying to be more active and give back to the community, writing articles about Swift UI or the Swift language evolution, which is really something that passionate me. Uh, but this year, with the rise of AI, it kind of made sense to me to explore some stuff that AI may not know all about, and that would be private APIs. I kind of hope that with this talk, I may answer some questions from yesterday's Q&A after Guillermo Rambo's wonderful presentation about liquid glass. So private APIs, they're also referred to as non-public APIs or even undocumented APIs. And the platform we work with allow us to write in different languages. So we could call them wonderful worlds because they're different worlds of and different kinds of approach that we'll both overview today. But let's start with this quote: "Why join the Navy if you can be a pirate?" That's what Steve Jobs said one day. And who said, "We found that your app uses one or more non-public APIs." Well, that's the App Store review team. Yeah, shit can happen. And I need your attention on this. I want to make it clear that the goal of this presentation is not to tell you that you should be using private APIs. I'm not here to tell you how to pass the App Store review team and like using some private APIs. I know they can be unsafe, and I believe we can work around that safety, but that's also not the debate today. I'm here to share with you the fun I had rediscovering or discovering some of those private APIs. So let's start with a story of how I got back into this wonderful subject. I was having fun recreating in SwiftUI the interface of the camera app until I came across this freaking icon. I looked everywhere. I went to SF Symbol, um, the app, and the closest thing that I could find was this. And let's be honest, it's not the same. But later on, I came across this gist on GitHub that shows us that we can find some internal SF symbol in the simulators file system. And it tells us we can use a tool called Asset Catalog Tinkerer, created by Guillermo. And using that tool, I could verify that the icon I was looking for existed, and I could find its name, camera.name. Of course, I wanted to access it through code. And the gist also showed us how to use an Objective-C private API called UI Asset Manager. And that's pretty much how I got into the rabbit hole of private APIs. And yes, we call it educational curiosity. And maybe the talk before showed you that you may also use that for like bad stuff. But there are some legit stuff you may want to use private APIs for. This is like Alcove, an app that takes a dynamic island from the iPhone and brings it to the Mac. And of course, you need some stuff that are not public to integrate that deeply with the system. Or another reason might be to use some effects like this variable blur that Apple uses in their own OS. And eventually, you may find yourself wanting to create a developer tool that might need non-public APIs. I actually ditched my camera prototype and created a fork of SF symbols that allows to browse those private APIs. But let's get to the fun. How do we find those private APIs? And we'll start with Objective-C. I hope you guys love Objective-C. Um, you probably know that Objective-C has a dynamic runtime, and it offers some pretty self-descriptive methods, these that are actually written in Swift, that allows to like list all the classes, all the methods, and all the properties and IVARs for those who are familiar with Objective-C. And so we can find a lot of things and generate some headers. And back in 2002, some developers started to create something called a runtime browser, which allows to generate all the header files at runtime for any framework. And that's pretty much how, or at least one way, that you can find private APIs in Objective-C. Now, how do you use those? Well, it's pretty easy. You just bring in the header file. In doing so, I discovered some of the APIs that Rumbo talked yesterday, like CA package, CA backdrop layer, and such. And I was able to access something I wanted for a long time, play with this animation, also known as the airdrop effect. But that was not enough to satisfy my curiosity. And so I was like, can we find private APIs in Swift? And let me break it to you. Swift doesn't have header files. Duh. So how do we find those private APIs in Objective-C? So I took a framework of my own that I call Swift Connection. And when you compile it, you obtain a binary and a Swift module, which itself contain at least a Swift doc and a Swift interface file, which really just contains the declarations of the methods and the types. And sometimes you will have a private Swift interface file. That is when you use a language feature called @SPI. I'm not going to detail it today. It stands for System Programming Interface. And all you need to know is that it allows to distribute some APIs to a limited set of developers, those who know the SPI name. So why does that matter? Because they're APIs designed for other developers, even though they're private. And it's common knowledge somehow that Apple uses them a lot internally. So we could hope to find a Swift UI or Swift module that contains such a thing. And that would be in Xcode's SDK. But of course, Apple doesn't publish that private Swift interface. But another thing is cool with Xcode is that since 2015, they removed the binary. So we don't need to use a disassembly tool. But instead, it comes with what's called text-based description file. And all they do is contain a bunch of symbols that your app can link against. And those symbols are called mangle name. They're pretty human readable, but we can make it a bit better using a tool called SwiftDemangle to obtain an actual Swift function. And that is pretty much one way to find private APIs in Swift. Now, how do we use it? Well, we can't just bring the header file. So I tried, and I was like, that's kind of crazy. You can just edit the Swift interface file. But in fact, you can. And I did add a glass variant type that actually exists that belongs to SwiftUI material. But let's be honest, it's really not very convenient because you have more than one Swift interface file, one for each platform, one for each architecture. And also, you can't expect other developers to do that in order to use your library or whatever. So there's a better way. You can use a language feature called Silgen and it serves two purposes. This one we don't really care about, but when you have a method that has a body, using Silgen name tells the compiler to not use the mangle name and look for hello_world as a symbol. But if you use it on a method that doesn't have a body, then it actually tries to find a symbol called hello world and will try to link with it, which in this case would fail. So let's take an actual mangle name that may work. We'll demangle it into a Swift function that takes the glass variant as a parameter, and we just apply Silden name. And doing so, we can actually find about a bunch of presets that Apple uses in their own OS for the liquid glass variants. And today we kind of saw like how to find and use private APIs in Objective-C, and also how to find and try to use private APIs in Swift. The truth is that Swift, with its complexity of protocols, generics, and such, make it a bit hard, and it's really less convenient. And let's be honest, the cool APIs still are part of the Objective-C. Like core animation is freaking amazing, but I feel like it's important to stay on top of this because Apple is slowly translating some of their framework or adding new one purely in Swift. And it's something really under active development. And this year, some developers started to create the 20 years younger version of the runtime browser for the runtime viewer, which is not really at runtime, but it allows to browse some private Swift interface. I really had fun digging all this, and I hope maybe you will too. Someone once said, "Stay hungry, stay foolish." Thank you.
All right, so I guess the question I have for you is you've told us we shouldn't use private APIs and we shouldn't aim to sneak private APIs into our apps, but we also use external libraries. And do you know if there are ways to get some confidence that a library isn't using a private API without us being aware of it?
Well, I think it would be a mistake as a library to distribute something private unless you're very explicit about it. And there's actually an amazing library that brings tons of stuff, not Objective C or Swift, but it brings stuff for Swift UI. It's called Engine, and it's actually developed by a former Apple employee. And it brings very cool stuff to Swift UI, but it's some C private API in the back.
I think what I had specifically in mind was the marketing SDKs, which tend to be sneaky because of just how they operate in apps. So if you've ever seen such SDKs like do things that could harm your app, is there any way you can defend against it, or you just have to
Mm.
trust whoever sends you the compiled library?
I mean, I guess using a disassembly tool, you could make sure of that, but that's something I don't really like to do. I guess I don't use so many third-party APIs, but or if I do, I use like uh, the known ones, which somehow you can trust. You know.
That makes sense.
Okay, so we have one that's a little bit more of a comment than a question, but it got all the upvotes. So this is from Guy Rambo that says, "Thank you for exposing all of my secrets."
They deserve to be known, honestly.
And then, I think the other question that we have is more sort of around what is sort of the policy around like, is it possible to get around doing this for Apple APIs? I know that obviously you can't be like, yes, totally, but like,
Just ask AI.
just ask AI. Gotcha. Cool. Do you have anything else?
No.
All right. Thank you very much.
Thank you,
Thank you.
guys.